Welcome back. We're working with direct variation. This is part 2 of the lesson. Using proportions in graphs. Now, remember, when we set up our ratio, one of the ways we can represent this was y over x equals k. So, some problems, we're going to be given some information. So, if this is a direct proportion or direct variation, when y is 9, x is negative 15. We want to find y when x is 21. Now, in order to do this, we can use a proportion. We can set it up just like y over x. So I'm going to take 9 over negative 15 equals, we don't know this variable, we're looking for y over x. Now whenever we have a fraction equaling a fraction, we can cross multiply. So 9 times 21 is 189. Negative 15 times y is negative 15y. When we divide by negative 15 now to solve for y, this is going to be bad. We get negative 12.6. And there's our answer. Again, I had to do some long division here to find my answer, but we were able to find it. You can use a calculator. So you can try this one. You can set it up using a ratio, using 2 fractions to set it up. Again, 15 over 3 equals, we don't know y, we do know x. Cross multiply, 15 times 12, 180 equals 3y. Divide by 3, and we get 60 equals y. This will also work if we're given y, but we have to find x. So we can set these up with fractions, we can cross multiply. And then finally, looking at how this looks like with a graph. And I know you're saying, graphs. But graphs are an essential part of mathematics, essential part of showing a pictorial representation of our data. So we know on a graph, we have an x-axis, we have a y-axis, and everything else. Now, how I know that it is a direct variation is it's going to be a straight line. But the key is, it has to go through the origin. Must go through the origin. So, I can tell you right now, and it has to be a straight line. That's a direct variation. That's a direct variation. That's a direct variation. That's a direct variation. So if you think back to lines, if you remember that, remember this is our y-intercept. Our y-intercept is 0. So any of these things will be y equals our constant or slope x plus 0. It's not there. So we're basically just graphing or counting our slope. So if we're given an equation y equals 5 halves x. When x is 0, y is also 0. When x is 1, our y is 2.5. When x is 2, our y value is 5. When x is 3, it's 7.5. And it's going to continue. Or it could be negative. Negative 1. And then negative 2.5. And we're going to see our line goes right through the origin, going at a constant rate, either increasing or decreasing. And every graph will look like this. So this concludes our direct variation part. So, very simplistic equations, things that will always go through 0 when we graph them. If we're comparing x's and y's, we can compare them using a ratio and using cross multiplying to solve for that variable. And from the previous lesson, knowing how to look at and setting it up where it's going to be y equals k times x or y over x equals k. No addition or subtractions in the equation. That's how we know it's a direct variation. And it's always going to increase by the same amount going up as it does going to the right. Same amount up, same amount to the right, or vice versa. Have a good day.